Hi, welcome to Pathways to Chemistry. Here we're told that at a particular temperature, Kc is 6.5 times 10 to the 2 for this reaction here. We're going to call this our reference reaction. And here we're asked to calculate K, or the equilibrium constant, for the following reactions. Let's look at reaction A first, and then we'll go to reaction B. So both reactions are identical except for the coefficients, all right? So let me go ahead and write the reaction quotient for our reference equation. And so that's going to be equal to concentration of the products. Remember, coefficients become exponents in the expression. Also remember that when you're writing these expressions, whether it be the equilibrium constant expression or the reaction quotient, you cannot have pure solids or liquids in the expression. Here we don't have to worry because we have gases, so we're fine here. So this would be the reaction quotient for our reference equation. So again, the only difference here is equation A was obtained from our reference equation by multiplying the coefficients by a 1/2, okay? So what I can do is I can go ahead and put the 1/2 here as an exponent, right? And I end up with the reaction quotient for reaction A. So basically, this equals my reaction quotient for reaction A. Okay, so, well, if we have that settled, so now we can relate that to the equilibrium constant. So if we have all equilibrium concentrations, we can say that the equilibrium constant for reaction A is going to be equal to the equilibrium constant for the reference to the 1/2 power. Okay, so what we have is 6.5 times 10 to the 2 and to the 1/2, or that's the same as taking the square root here. So for this particular calculation, 6.5 times 10 to the 2, the square root of that is 25. So in general, when you multiply the coefficients of an equilibrium reaction, whatever factor you multiply those coefficients by will become the exponent in the reaction quotient or the equilibrium expression. So we have to treat the magnitude of K the same way. So again, the factor that we multiplied our coefficients by becomes the exponent. Now, let's take a look at B. And again, we'll compare B to our reference equation, which is up here. And notice the equation has been reversed. So anytime we reverse an equation, the new K, going to be the equilibrium constant for reaction B, would be the reciprocal of K for our reference equation. Now, I also noticed that the equation has been multiplied by 2. Notice we have, in this case, nitrogen. We have 2 nitrogens, 4 waters. Okay, so this has also been multiplied by 2. So it's been reversed, multiplied by 2, and so that means we multiply those coefficients by a factor of 2. 2 becomes our exponent here. So what we have is we have 1.5 times 10 to the 2 to the second power. So K for reaction B would be equal to 2.4 times 10 to the negative 6. So again, if an equation is reversed, then we have to take the reciprocal of k. If an equation is multiplied by some factor, that factor becomes the exponent.